Hey, I'm finally back with another video. It's been quite a while, a couple months at least, which is long for me. I wanted to get back into some electronics projects. I really want to get back into playing some drums too. I haven't played drums in a year, but been working on projects around the house, plumbing problems, things like that. But the latest thing I've been doing that's been preventing me from doing any more electronics projects, even the drums, is rebuilding my workshop, which what you're looking at now, this is the same place that I've made the previous videos. It's the same room in the house, little utility room in the basement, and it was kind of dark and dank and damp and musty. So completely gutted it, painted the floors, dry locked the cinder block, dry locked the floors, painted it, built a new workbench right there. That's new. Put some new lights up. Totally rearranged. I still haven't connected all this equipment yet, but I got my basic bench ready right here, ready to do some work and some soldering. Put some new shelves up. Got a new toolbox. That was a Black Friday special. So this is the electronics side right here, and the other side, which was really nasty before, is now got a new workbench over there, and that's now all for just other projects other than electronics, woodworking and household type projects over here, drilling and sawing and that sort of thing. Those lights right there are new. It was really dark over here before, and had all the shelving, just rearranged everything and painted for to get things a little more bright. It's kind of dark in here, and that curtain there, which is a shower curtain actually, is hiding the furnace, which was really nasty looking. It's old. Thing is ancient. The boiler, and that's a water baseboard water heat. So there it is. This is the new workshop, and I just finished it about a week ago. I've gotten everything put back into place and ready to start a new project. And the new project is, I probably haven't finished. I don't think I've ever finished anything. I get close, like these tube amp I get close to finishing, and then I just get bored with it and want to move on. It's pretty bad, but anyway, I want to play some drums. It's been a while, but my speakers, I got these crappy speakers here that I like though, and I blew the tweeters in them. And this is a no-name brand. I don't know what they are. There's not even a brand on them. Made in China, no doubt. Total crap. But I blew the tweeters on them long ago, and they're really cheap piezo electric type style tweeters. And I want to fix them. So I'm going to take those apart, and I don't even know what kind of crossovers they have in them and what the crossover point is, but I went ahead and took the measurements. That's where took the tweeter out of that one. Took the measurements, and I purchased some parts. Bought an L pad. That's a level control. It's an L pad that I want to install, because when I put the new tweeters in, they're not going to be matched in level. And so I bought an L pad with the little level control thing, the knob. And I bought some compression drivers. I got a good deal on these things. These compression drivers from MCM Audio Select, company I never purchased from before, but they have some cool stuff there for hobbyists. Really cool stuff there and good prices. So I bought some real compression drivers because what came out of those speakers, what's in there now are piezoelectric, which are just, put this down, the cheapest of the cheap, like total garbage for tweeters. And of course they blew, but these are going to need, when I hook these up, I need to figure out what the crossover frequency is and choose the correct capacitor for them. Have not yet to open these. And I bought these compression drivers because they look like they have from online, they have a good smooth frequency response and decent power handling. Let me put this down. And more importantly, they seem to be of the right dimensions, or close to the right dimensions to fit in the existing slot. Let's see what that looks like in there. If I can get a picture down in the throat. Can't tell what's. It's definitely a compression driver. You can't see the diaphragm. It's not like a horn tweeter that has a diaphragm and just a horn, just a horn front. This is actually a genuine compression driver, which is completely different. Completely different design than just a regular dome tweeter that has a horn on the front of it. It says 140 watts max, 8 ohms. That's good. I don't think I'm going to blow these. But anyway, it's pretty cool. Got a good price on these. So what I need to do, and this is the next project because I can't play drums without these things. I want these fixed first. Is I'm going to try to do a project from start to finish. Now, I'm going to replace the tweeters, figure out what the crossover point is, choose the correct crossover, install the. Oh, why is my camera focusing? There we go. Install the L pads and try to figure all that out. I don't have the equipment to really test loudspeakers, but I'll do the best I can with what I have and try to figure out what the crossover point is currently so I can match these up, and pick the correct capacitor to put in series with them. And we'll get them running. And I figured I'd go ahead and film this project for anyone interested. And once I get this finished, I can get back to playing some drums and playing some new songs. I really enjoy doing. I haven't done that for a year. Haven't even picked up a drumstick. So, and this will be the first project I do on the new workbench. Got these new. I just built this bench out of most of the stuff I had the wood on hand, but I bought these power strips, which are protected. Love these power strips. Really long, spaced out. You can plug just anything in there, not have these large transformers sort of bump into each other. I bought one for this side, for the electronic side, and then I bought one for this side over here. Got a little space heater hooked up there right now. So I got one back there. Just bought that little vise. Got that vise for $20. Little cheap piece of junk, but it'll do the trick. So anyway, that's the project. I think the first thing I'm going to do is remove this this old tweeter and kind of take it apart, see how it works, test it, see I can figure out what went wrong with it, just for fun. And then I'm going to have to figure out what the crossover point of the woofer is, and then figure out how to pick the correct capacitor to put in series with the compression driver, and then test it to make sure that the crossover point is where it needs to be, and then physically install the thing. I might have to do some cutting, and then install the L pads, and then just once I get the crossover in and the L pads in, then we can just adjust the level of the tweeter basically by ear. That's all it needs to be. So that's it. That's the latest project. I'm kind of going to try to do this one start to finish without doing what I've done in the past and not finishing what I started. Get this. I'm sure that some of those other videos I made on the tube amps that I never really quite finished, but I'm at the point where I got to move on. Alright. So I'll hit pause here and gonna go ahead and remove that old tweeter and take a look at it, see how it works. Alright. This is, I don't even remember where I bought these speakers, but they were they were something like $60 each. For PA speakers, that means you're getting total crap. But hey, they work. The woofers work. They produce the sound that just what I need for playing drums. Didn't need anything expensive. I don't like buying stuff that's too expensive, because then you gotta care too much about it. I like stuff I don't have to care too much about. Okay, here we go. No, this is a. Okay, there's a. There's a resistor on the back. This thing is so light. It's like it's the lightest speaker the lightest tweeter I've ever felt. Total plastic, you know. It's like the weight of a credit card. It's amazing, even with the resistor on the back. It's a 5-watt, 60 ohm resistor. Let's go ahead and get this cut. Okay, go ahead and take the woofer out, because I need to see if there's what kind of crossover we're dealing with. Because that's a piezoelectric, I'm sure, because you can kind of look in there and kind of tell. Big diaphragm thing, and piezoelectric tweeters, which I mentioned earlier, are the worst. It's total crap. It's the cheapest, worst garbage there is, which is to be expected when you buy a $60 PA speaker. I'm not complaining, but those things operate on a completely different principle than the normal dynamic driver. You know, a normal tweeter would have like a dome or a cone, and it would have a voice coil that rides inside of a magnetic gap. And piezo doesn't operate that way at all. It's just a little piece of metal. Literally, it's a little, like a quarter size or a dime size piece of some kind of piece of metal. I think it's metal. With the leads directly to it, and the wires. Well, I'll take it apart and show you. And when you apply a voltage between the two wires, current runs through the piece of material, the piece of metal, and the thing, in response to that, actually changes shape. And that change of shape produces sound. So believe it or not, there's no crossover. Literally, there's no crossover in here. The terminal strip on the back is connected directly to the woofer. Directly to it. There's no crossover. And then the lead to the tweeter, there's no capacitor, no crossover, nothing. Which you can get away with a piezo. You can't get away with not having a crossover with any other style with a dynamic driver. Compression, none of that. You know, any driver that has a voice coil, you need a crossover, because you can't send low frequency. That's probably why this thing blew. because you know all the frequencies, including the low frequencies, are going to this little tiny driver. I crank it up kind of loud when I'm playing the drums. So this woofer, again, there's no crossover. This doesn't need one. This is it. You know, this driver itself naturally tapers off after a certain frequency, probably 1 to 5 kilohertz. So it can be its own crossover, so to speak, but not a lot of dust. But the new compression driver is going to need a crossover, and that's what we need to figure out. That's what we got to figure out, is what that frequency, what that crossover frequency needs to be, and I'm not sure how to figure that out yet. Never had to do it before. Okay. So, let me see here. I'm just doing this without a cut. Okay. Alright, so we have, this is total junk, never going to use it again. I'm not even going to try to save that. Well, I like saving parts. That's a 5-watt, 60 ohm. But that's not worth saving. If I need one of those, I'll buy another one. Get another one at Radio Shack, or if they're still in business, or online. It's one thing I keep hearing, Radio Shack is going to go out of business, man. I've been buying miscellaneous little odds and ends from them for years. It's going to be a shame not to be able to just go right down to the store to buy a standard, you know, resistor or something you need. But you know, it's not like you can't get everything online. It's just real convenient to have Radio Shacks around. Okay, so hoping you can see this. This is piezoelectric, so literally the leads, positive and negative, come in and they're soldered right to this little diaphragm. I'm going to go ahead and let me cut this off and try to see if I can take it out. Well, oh, there it is. Okay, so this is just the horn itself, plastic, and let me take this out. Well, okay, well, no wonder it didn't work. That one lead was already broken, so I could probably fix it by soldering. I don't want to fix it. I've got those compression drivers. So how does a piezoelectric tweeter work? Well, there we go. So this little wafer thing here is a little piece of metal, and one lead is soldered to the back side of it, and this other lead kind of goes to the rim. There's like a little rim around it. So the current flows through the material from one lead to the other, and this material kind of flexes and moves around at the frequencies it produces, high frequencies, and creates sound just by the metal flexing. Kind of just, I think that it creates a wave right through the material. And then the middle of this piece right here is attached to a cone. It would still, you know, if you pulled this material off, it would still make a sound, but attaching it to the cone mechanically amplifies the sound. And then this cone right here will pretty much went into the horn, the throat of the horn, and there it is. So no voice coil, no magnet needed, nothing. Cheap garbage, but it works. I wonder if, what if I put a signal into it, just like that, what it would sound like. Maybe I'll give that a try just for shits. Okay, I went ahead and putting a signal into it directly from my function generator, a sine wave, and it does work. Change of frequency. This is not even through an amplifier of any kind. This is just directly from my sine wave generator. That makes it louder. Horn loading it. So it works, but the problem was a broken lead. I guess probably I just put so much power into it without a crossover. It just melted the lead. But that's okay because, like I said, I want to go ahead and replace it with those compression drivers anyhow. So I'm just going to throw this thing away. Wonder what the resistance is through a piezo. You know, normally, you know, a dynamic voice coil style driver would be, you know, 8 ohms, 16 ohms, 4 ohms, but a piezo is going to be much, much higher. Go ahead and measure the resistance. I don't even know what it's going to be. I guess it's in the hundreds of ohms. Okay. Can't even get a reading. Here we go. Mega ohms. What? I'm not even getting a reading. I wonder why. It's like I have a bad connection or something. That's weird. And it says over. Not even able to get a reading. It's like it's infinite. Yeah, I don't know how that works. I'm not getting a reading at all. It's like it's the meter's thinking like it wants to come up with something, but every now and then something pops up like 37 mega ohms. So I'm not sure how that works. Maybe there's really literally no physical connection. I think that must be how. I gotta look up how a piezoelectric effect works, but there doesn't seem to be a direct electrical connection between the two leads. It's like two different strips of material, one on each side, that are separated by an insulator. Maybe that's how it works. You know, I should know this before, but I don't care. That'd be something interesting to look up, is how the piezoelectric effect works and how it's, you know, how these tweeters are designed. But not even able to get a reading on that. Probably it's there's no DC resistance. It's probably there's probably an AC reactance. And if you put you'd have to measure it using an AC signal. Measure the current flowing through it, the voltage across it, and get the AC reactance. There's probably no DC at all, no DC resistance, I'm guessing. I'll have to look up how that works. But anyway, that's junk. I'm going to throw it away. I don't want it. Save these screws. Okay. So that's enough for tonight. It's late at night. I think, well, the first thing I need to do is I want to figure out the crossover point of the woofer. Very roughly, I don't need anything, you know, to scientific accuracy, but I need to know about where the woofer crosses, about where the woofer, the negative 3 dB point of the woofer. I'll just put a signal into it and have to do that acoustically. I'll take a little audio recorder device I have and measure the acoustic output, and it's got a decibel meter on it, and when it gets down to negative 3 dB or so, then I'll figure out what frequency that is, and that'll be where we design the crossover for the tweeter. Okay, well, thanks for watching. That's off to another project, first project for the new workbench. My darn old, I mean this is old, but my frequency, my signal generator, it's interesting. My the display normally reads frequency is not working. Gate. It's interesting. There's, you know, usually I get the frequency readout here. Nothing. I know it works because I just use this to put a signal into. Bummer. I don't know when that stopped working, but hey, maybe I gotta spend a little bit more money on equipment. Bought this a long time ago. I don't know when it was well, maybe it wasn't that long ago. There's a calibration sticker on it. Oh, 2002. Well, I guess that's a long time ago. So I'd love to know why my frequency counter doesn't work on this thing. It's a pisser. Okay, well, that's how it is. So thanks for watching. I'm going to continue on with this latest project. Sorry I'm so sporadic here. It's like 2 in the morning, 2 days before Christmas, 2014, and I haven't made a video in a while, so I thought I'd just get started. Obviously I don't have a script. I just do it spontaneously. So it's I'm sure these videos look pretty unprofessional, but that's the way it is. Otherwise I wouldn't put a lot of time into them. I wouldn't make them, but I'm glad hopefully someone gets something out of them. I don't know if anyone's going to dig this speaker repair thing, but someone might. Man, it's raining like crazy outside. Okay, thanks. I'll pick up with the next step is, like I say, checking for the crossover frequency of the woofers, and for that I'll probably have to take the speaker outside, away from internal room reflections, and face it out into the wide open, and set my microphone up and signal generator and measure the negative 3 dB point of the acoustic output of the woofer while keeping the signal constant to the input, and get a rough idea where that is, and go from there. Thanks for watching. Good night.